Streams allow to convert big amounts of data into manageable chunks. So what does it mean, and why should we bother about streams? When I say streams, the first thing that may come to your mind is video streaming. It's a very common example. We have a large amount of data, a movie file, and a client. The client wants to see a movie in his or her browser via HTTP. But the client doesn't want to load the whole movie at once, because the connection may be slow. Instead, we want to break this large movie file into chunks. So, we load a buffer of chunks at a time. Some amount of chunks is stored in a buffer, and then it goes as a whole thing to the client. Streams play a huge role in event-driven asynchronous application. They are the basic I/O in ReactPHP. We cannot wait until the whole resource will be loaded into memory, because this may take some time and block an event loop. Instead, we load the resource by small chunks, or line by line, and so we can immediately start processing it. Consider streams as collections of data, like arrays for example. The only difference with arrays is that the stream data might not be available at once. That means that streams don't have to fit in memory. In ReactPHP we have three types of streams. Readable streams that can be used only to read data from a source, writable streams that allow only to write data, and duplex streams that are both readable and writable. Essentially, they are a readable stream and a writable stream combined in one single object, each with its own buffer. A good example of a duplex stream is a TCP socket. A server may read data from it and then write something back to the client. I think we are done with theory and it's time to write some code. First of all, we need to pull a package that implements streams. You can find it on the ReactPHP official site. It's called Stream. Copy this, paste and run. To create a read-only stream, we use readable resource stream class. Its constructor requires two arguments: a resource opened in a reading mode and an event loop. As a resource, I will use a predefined constant for standard input. All streams are implemented as event emitters. They are able to do stuff when they receive data or when data is finished. It means that we can attach handlers for this event. When we read data from a readable stream, it fires data event for each received chunk. To try things out, we can simply echo this chunk. And don't forget to run the loop. Here I echo a string and pipe it to PHP standard input. Then the script prints it. Now I have a large file of 180 megabytes. Let's read this file and see what happens. It reads the file line by line, despite its size. If we try to read the same file with file_get_contents function, with my PHP setup, I receive an error that the file is too large. You see that with streams there is no need to load the whole thing into a memory. Data is not the only event we can listen to. When the source has successfully reached the end and there is no more data available in it, the end event is fired. Streams are very flexible and you have full control over the reading. For example, we can change the buffer size. Let's read one character for a chunk. You can pass this limit as a third argument of the constructor. Now we have each letter printed on its own line. Also, we can pause and resume the reading. To demonstrate how it works, I will use timers. For each chunk we are going to pause, and then in a second we continue reading. I will skip some letters and we are done, one letter every second. To create a writable stream, we need the same set of arguments, a resource opened in a writing mode and a loop. Then to write something to the stream, we can use method write. You see that we use standard output as a stream. That means that we can print data to the console by writing this data to a stream instead of using echo. Let's create a readable stream, and when the stream receives a chunk of data, we simply write this data to a writable stream, like this. And it works as expected. Notice that I use pipe here. It takes output of this command and then uses this output as input for PHP script. Now, take a look at what we are doing here. Again, we use output of this stream as input data for this one. It means that this code is piping. We can rewrite it with pipe method, and it will produce the same results. Only one line of code instead of listening to different events and manually processing the data flow. Behind the scenes, pipe method subscribes all the required listeners and calls the appropriate methods to provide a continuous flow of data between the streams. Piping is a very powerful tool. It allows to chain different streams, and each stream will be responsible for its own job. For example, we create a through stream, which works like a transfer stream. Its constructor accepts a callback that will be used to process the past data. Consider a through stream as the following. You write data to it, this data is being processed, and then you read this processed data from it. Streams are very important in a synchronous world. They allow to process large amounts of data, or data that is coming from an external source in chunks. At the same time, they are a very low-level abstraction, where you have to manage all the events and data flow by yourself. But on top of this abstraction, you can build high-level components or protocols. For example, when we are working with sockets or HTTP connection, we should consider streams.